Uh, Good day, everyone. I'm Chun-Hsien from National Taiwan University, Taipei, Taiwan. The title of today's presentation is an evaluation data set for legal words embedding, a case study on Chinese Codex. This is today's agenda. Today, I would like to share about word embedding evaluation data set, especially for legal professional in Chinese. Word embedding is a modern distributed word representations approach widely used in many natural language processing tasks. Most general purpose applications apply the evaluation benchmark data sets released by Google, as not as Mikolov, to assess their word embedding. For Chinese, the evaluation benchmark dataset was translated from former by the CKIP group. However, the general purpose word embedding model cannot fully meet the task requirements of the specific fields, such as biomedicine, financial opinion mining, the legal professional, and so on. The famous word embedding model is proposed by Mikolov. In his paper, he presents a simple algebraic calculation as an analogical reasoning to assess a word embedding model. For using this simple algebra calculation as a word embedding benchmark, we need a question words set to be a test bed. This is a benchmark data set released by Google. As you can see, there are 4 relations in the question word set. Okay, yeah, here. This is the benchmark set that was translated by CKIP group. As you see, there are many kinds of linguistic relations does not map to Chinese, such as opposite, comparative, past tense. This is the benchmark set for simple Chinese released by Cheng. The relation in the benchmark are based on Chinese morphological and semantic relations. Shelley described the feature of the data set in detail in his paper. If you are interested, you can read this paper directly. We will not go into details here. This is our work pipeline. The left-hand side, LARQS is our goal. The start point is from data collecting. From here, data collecting. Next, we can do some text preprocess. Then training model, selecting the term into our benchmark set manually. The dot line is the iteration path. This is the data source of our corpus. We write a crawler to collect the text of the articles, then use a series of tools to dealing with this text, such as word segmentation and something cleaning. Our main programming language is Python. And let's take a glance at our data set. The data set original is a parallel corpus that goes with Chinese and English. This work uses the Chinese part only. These are the tools used for our experiments. The tool used to build the Chinese word embedding models in our work is Chun-Hsien. Is here. Even using the existing tool, the hyperparameters for the training word embedding model greatly influence the final quality. Therefore, to explore the best possible hyperparameter, we select several hyperparameters such as the vector size of word embed iterations, training iterations, and the window size for the experiment.
我不太清楚你想表达什么。
When it comes to Chinese natural language processing workflow, the first obstacle is Chinese word segmentation. Moreover, the accuracy of a Chinese word segmentation result has a varying degrees of impact on subsequent downstream Chinese natural language process task. To reduce the error rate in this task, it is thus imperative to choose the most appropriate Chinese word segmentation tools. As you see, Chinese sentence has no splitter, such as a space character. After we collect and clean the text data into dataset, next we need to do is word segmentation, as the red row. There are many existing Chinese word segmentation tools, such as Jieba, CKP tagger. We choose CKP tagger. After word segmentation, we apply TF-IDF to observe our data set. The red line is TF. The red line is TF. The green line is IDF, and the blue line is TF IDF. The term with high TF IDF value is more occurrence, somewhat similar to English subwords. We focus on the term with lower TF IDF because it may be got a wrong word segmentation. Then we correct it manually iteratively. As you can see, there are four kind of a relation of legal relation. This relation is decided from legal expert. Legal expert choose these 5 legal relations from Codex data set. McLove proposed 2 models for building word embedding. The left-hand side is C-bow, and the right-hand side is the skipgram. As you see, skipgram has better performance, so we choose skipgram for our experiment. As we create a word embedding model, we need a visual tool to explore term relations. We use TensorBoard, which can do this work well. Loading the text word embedding on the left-hand side panel. Here. You can see here it is a low bottom. Input the term into the right-hand side search fields, applying TSNE to downgrade the embedding dimensions, then explore the relative terms in the middle window. Finally, more close relation will be grouped. We can pick the relative term into our benchmark set. We use 4 benchmark data sets to evaluate the word embedding model made of the codex corpus. As shown in this figure, the LARQS is our data set. The LARQS data set performs outstanding among the 4 benchmark data sets. Something about Google, the simple Chinese. Simple Chinese has 2 data sets, and the purple line is our LARQS data set. This is the table about the previous figures. As you can see, our data set has the best performance. To explore whether the LARQS data set made of the legal relations is only suitable for professional fields of law, we use the same 4 benchmarks to evaluate the word embedding model made by the Chinese version of the wiki. The result shows that the performance of LARQS is still the best in the 4 benchmarks. You can see the purple line is on the top. This is the table about the previous figure. We collected the legal provision of laws and regulations promulgated and implemented in Taiwan as a codex corpus for experimentation. We trained a legal word embedding model based on this corpus and released it to public for future research. We established and released legal and logical reasoning questions set, as known as LARQS, with 5 categories of legal relationship from the corpus mentioned above to evaluate the accuracy of Chinese word embed from the perspective of legal relation. We assess the accuracy of several word embedding models with the Google evaluation benchmark data set. Our conclusion is that, generally speaking, the evaluation benchmark data set is not suitable for the legal professional. We discovered the legal relation may be ubiquitous in the word embedding model. The evaluation benchmark data set based on the legal relation can better demonstrate the relationship between the word in the word embedding model. Considering only linguistic features is not enough to assess the word embedding model built from the codex. The significance of the accuracy evaluation based on the evaluation benchmark set, which collect non-general specific relationship, is not significant. For example, the relationship between the US state name and the city name in the state. The last LARQS data set established its manual, and the number of questions is only 1,000 more. Feature work. we will find more relationship in order to enrich our LARQS data set. We hope that the automatic method will be developed to unearth additional legal relation and enrich the LARQS data set. And assist the legal ontology construction in the lexical layer. That's our future works. And any question?